instead of series RLC circuit, they may give parallel RLC circuit. Again, in the parallel circuit, I already told no, they will usually give the switch is opened, but in this case, the switch is placed series, not parallel. So that's why in this parallel problem also, they had given switch is closed at t is equal to 0 because it is not connected. The switch is not connected parallel to RLC. It is in series with the current source. So that's why it's given switch is closed. So before the switch is open. Before the switch is open means for t is equal to 0 minus, for t is equal to 0 minus, switch is open. No, so no current through R, no current through L, no current through C. So initial current in the inductor is 0, initial voltage in the capacitor is 0. So we are measuring voltage across. This is V of t. This is V of t. So that is nothing but is a single node. So voltage across this one is 0 because current is 0 in the resistance. So 2 into 0 is 0 volts. Now the switch is closed at t is equal to 0 plus. Now the switch is closed here. Now the switch is closed here. But the behavior of the capacitor, how it behaves. For t is equal to 0 plus, capacitor I told no battery. Immediately it acts as short circuit, but inductor acts as open circuit. So now see in this circuit what happens. Inductor acts as open and capacitor acts as short. So whenever short circuit is there, all the current flows through short circuit path. All 10 amps flows through here. Here current is 0 amps. So V of 0 plus is 0 volts because short circuit, full current short circuit is 10 amps and resistance is 0. 10 amps into 0 is 0 or 2 ohms into 0 current is also 0. So IL of 0 plus is 0. Here current, since it is open circuit, current is 0 and voltage across capacitor, still it is 0 volts. Coming to this, for t greater than 0, you have to write, for t greater than 0, switch is closed now. And you have to write KCL. Current going to the node is 10 amps and current leaving from the node is 3 currents. Okay, it is 10 is equal to, okay, 10 is equal to this voltage. It is nothing but this voltage. This full node is V of t only. This voltage, it is V of t by 2 because if you consider this is a ground, potential difference V of t minus 0 by 2 and current through inductor and current through capacitor. Current, since parallel circuit, current through inductor is 1 by L V of t dt. Current through capacitor is C into dV by dt. Is 1 by C, sorry, 1 by L, 1 by L I think. 1 by L integral V of t dt plus C into dV by dt. So that is V of t, wherever V is there, no, you write V of t. Okay, V of t by 2, 1 by L value is 1 Henry. V of, wherever V is there, no, you write V of t. V of t into dt and C value 0.5 10 power minus 6 dV by dt is equal to, current going to the node is 10. Now we have to find dV by dt. Already dV by dt term is there. Already dV by dt term is there. So substitute t is equal to 0 plus. So if you substitute t of 0 plus, I told no, write V of t also. So t value substitute as V of 0 plus by 2 and delta t is given 0. Okay, this is just instant, no? Just after the instant delta t is 0. So it is 0 only. Delta t is 0 means 0. So this current is 0 and this C value right as it is dV by dt. Now this part is 0. What is V of 0 plus? V of 0 plus is also 0 I think. V of 0 plus is also 0 plus. So this is also 0. Second term is also 0. So dV by dt is equal to, will become 1 over 10 divided by, it is equal to dv by dt 0 plus is equal to 10 divided by 0.5 10 power minus 6. So take the calculator. Take the calculator. Now we'll do 0.5 10 divided by 0.5 minus 6. We'll get, press ENG button. 20 into 10 power plus 6. 20 into 10 power 6 volts per second. So this is one answer we got. So next we have to find out d²v by dt². So you have to differentiate this equation number 1 once again. So if you differentiate, v is become dv by dt, half dv by dt, half dv by dt of wherever v is there now, you have to write v of t. Okay. And integral and differentiation will get cancelled. Integral and differentiation will left with only v of t. You will left with only v of t. C d²v by dt². Again substitute at t is equal to 0 plus half dv by dt at the time t is equal to 0 plus voltage at the time 0 plus and d²v by dt at t is equal to 0 plus. Now we already have v of 0 plus is 0 and dv by dt is equal to 10 t into 10 power 6. So this is 0, v of 0 plus is 0. Okay. And we have half dv by dt 0 plus is 20 into 10 power 6. So it is 10 and 0.5 10 power minus 6 d²v by dt² is equal to 0. And you bring this 10 power, this I will write here, d²v by dt² is equal to, you bring this 10 into 10 power 6, 10 into 10 power 6, that is becomes minus, this becomes, you bring it to right side, it becomes minus, and this term should come denominator because this much is equal to this means only this part is, you have to divide by this, so it becomes 0.5 into 10 power minus 6. 10 power, this is plus 6, this is plus 6, 10 into 10 power plus 6, this is 0.5 into 10 power minus 6. Okay, this plus 6 and minus 6. Okay, plus 6 and minus 6, I take here, so minus 10 into 10 power plus 6 divided by 0.5 10 power minus 6. See, minus 10 into 10 power 6 divided by 0.5 into 10 power minus 6. So into 10 power x you have to use this. If I click this, you'll get minus 2 into 10 power 12, or if you click ENG button, if I click ENG button, you'll get minus 20 into this is correct answer. Okay, same answer here also we are getting. In both the textbooks we are getting the same answer. So this is also important problem. You have to, don't make any mistake. Please see here, this concept is whenever you have short circuit, all the current will go through short circuit, no current is flowing through this. So V of 0 plus is 0. Just after switching, inductor acts as open, capacitor acts as short. This is also important point. and for t greater than 0 apply KCL. Okay, for that you remember the table I shown, and this carefully you have to do because you have to substitute dv by dt in the next equation. So don't make any mistake here. If you make any mistake here, in the next step also you're going to get wrong answer.